Hello everyone. So again I got a suggestion to solve this problem. Subarray equals sum k. Okay, subarray sum equals k. Okay, let's see the problem, what the problem is. Okay. It looks like there is some subarray and I have to equals the sum. Okay, no, oh, okay, I have never submitted this. Given an array of integers nums and an integer k, return the total number of continuous subarrays whose sum equals to k. Yeah, it is like pretty simple question. What you have to do is you have an array like 5, 4, 5, 3, 2, 6, something like this. Okay. Then you have to count total number of, oh, it is again a sliding window problem. Okay, these are like simple. If you know that it is sliding window, it won't take too long to solve this. Okay, so let's suppose, okay, if array is this, we can take 8. Let's suppose k is 8. Okay, so 5 plus 3, 8. 3 plus 2 is not 8. 2 plus 6 is 8 again. Oh, but the thing is, what should be the length of subarray? Yeah, so for that, what we do, we will check for first. Okay, if this 5, this 5, okay, let's alter the situation. Let's take another array. Why I'm taking this, you will know after some time. 5, 3, 10, 2, and 6. Okay, and one more, 2, 4, 4. Yeah, so let's start from traversing from first. We will see that our current sum is 0. Let's take current equal to 0. This is sum of total, like it is just total sum. Okay, so we are at index this. If we check that 5 is less than k. Okay, so if 5 is less than k, we can update current as 5. Now current will become 5. Then we go to next element, it is 3. Cool. Then we will check, is current plus 3 greater than 8? If it is, then break. Okay, we not break, then okay, we can take 2 pointers, left and right pointer for each of them. So can I guess positive number should be there inside. Oh, num psi can be negative also, so that's an issue. And the length of nums is 10 to the power 4. Okay, this would be okay. If that's the case, then we have to do something like we have to find. Okay, so in this kind of question, what I can do is, for any ith index, like if it is ith, I want to check how many arrays are before it, which, okay, how many subarrays are before it, which we can get through like putting 2 at this place. Okay, so it finally converted into a DP kind of question, DP question. Okay, so it is a DP question then. But the constant is 2 into 10 to the power 4. So DP won't work directly here. We have to we need some optimization. So what we can do, if the subarray is ending at 5, we just go on. Okay, if it is ending at 3, we have to maintain a prefix sum. Okay, so let's maintain a prefix sum array. It will be 5, 8, 18, 20, 26, 28, 32 and 36. Cool. Now while going onward, if this 8 is greater than k, okay, it won't work. Like, we have negative elements. That's the biggest problem. We have to use directly dp, and k can be 10 to the power 7. K let's see. So we have our prefix sum. We are at here. This is not always increasing, that's the point. Like, the array could be 5, -2, 3, -1. Okay, or let's suppose this is -2 also. So the prefix sum will be 5, 3, 3, 2, 3, I mean 5 minus 3, 3, 3, 9, sorry, 3, 3, 6, and 6 minus 2, 4. Okay. So for 5, we go forward. For 3, we'll check all the possible cases. But do we need to check all the possible cases? We need k is equal to some value. Okay. This is 2, this is 6, 2, 4, 4. Okay. If you are at any index I, k is 10 to the power 7. So we can't store all the i's also. Like, for k equals to some value, k. What are the things that we can store? If sum is 10 to the power 7, we can't store all the values too. But we can use dictionary then to k is from 10 to the 7 to -7. Let us suppose, yeah. So we will traverse from left to right. For each I, so the thing is, there is something plus an element at ith and plus like array of I, which is gonna be k. Okay, and this something is also summation of others. So this can be in order of n square. This is in order of n. The real problem is, like, if we are going forward, and if any element is negative, then there are chances that excluding it and including it will suffice our purpose. Or we can go back also, like if this is I, this is minus, if I just check for it, 5 minus 3 and 2, and we are searching for, let's suppose we are searching for 4. Okay, our case 4, so we got 5. Okay, we can skip it. Minus 3. Okay, let's go forward. We found that there is 2. Okay, their sum is 1, so we will go back and try to find the best. Okay, yeah, I'm not able to find the real answer, so let's try to find recursive solution. Okay, so recursively what we have to do, we can simply pass the ith element and check for whether there is an element, and check for all the sums from left. If any of this plus this will be equal to the value, then okay, it's okay. Okay. It's already 11 minutes. Um, okay, let's check whether I'm wasting time or not. Is there out of n storage possible? Okay. Hashmap is used. Okay. Uh, that first was written Prefix-Sum plus Hashmap. That's also I used. It won't work directly. We have to do something good. Let us suppose we have our 5, 3, 10, 2, 6. Okay, so let's again take 5, 3, 10, 2, and 6. Okay, let's calculate its prefix sum. This is our array. This is prefix sum. 5, 8, 18, 20, and 26. So if we start appending for each I and j, it already crossed out of n square. Okay. Okay, there are hints also given. Okay, brute force work here, try to optimize it. So, optimization of brute force. If nums of I is negative, how could I optimize it? Let's see the second hint. Yeah, Prefix-Sum. Okay, some frequencies. Yeah, that makes sense. Oh, the thing is, I was doing the same. I was doing its like, oh, order of n square will work. Oh, I was thinking it like in a different way. But the thing is, order of n square will work. So what I was saying, whatever I was saying, let's take prefix sum array and find all i's and j's, pair of I and j. It will work. Okay, but the technically it shouldn't. See, we have 2 into 10 to the power 4. Okay, these much of arrays. Okay, so we will be around 10 to the power 8 instructions. Okay, but here 2 into 10 to the power 4, so it will be somewhat higher, such that n into n plus 1 upon 2, 2 into 10 to the power 4 to the power 2 upon 2, if we take each I and j, from I is from first and j is from last. So it will be like 2 into 10 to the power 8 operations. It shouldn't work, but maybe the test cases are like this that work. I should have tried brute force at first instead of taking the hint, but okay, it's okay, sometimes you have to. Okay, let's just simply then do the same thing. Okay, let's take a dictionary. I was doing same, actually you can see here. Yeah. Here I told you that not here. Okay, this sum plus this is equal to k. Okay, then why not we are going to take all these, like the number of these for the previous one, and find all the k's. It is similar to that, like finding all these and taking those count, and if it will be equal to k, okay, that's okay, we are going to append it. That's cool. That is same, like we don't have to do anything else. So we also don't need to use dictionary. Instead we can do for I in range n comma length of nums, say prefix sum array equals 0 cross length of nums plus 1. Let's take plus 1. Okay, then prefix-sum of I equals prefix-sum of I minus 1 plus prefix-sum of, not prefix-sum, rather it will be nums of I minus 1. Yeah, it will work. So for I in range length of nums plus 1 comma length of nums plus 1, for j in range k is not equal, okay, k could be 0. Okay, if that's the case, then I have to take I also. I in range I comma, yeah, it will work, I comma length of nums plus 1 again, length of nums plus 1, if Prefix-sum of k, instead I have to start it from 0. Yeah, Prefix-sum of I minus Prefix-sum of I minus sorry, I and j. Okay, why we have to use hash table again? Okay, every time whenever I do a sum, it is better to store it. See, using prefix-sum. Oh no, this is same as we thought. We have to take all the sums. There's no another way for now, until unless we try some greedy algo. If pre-sum of j minus pre-sum of I equals k, then okay, let's take our result count. Result count equals to 0. Count plus equal to 1. So it is accepted, but it won't work everywhere. Still, let's try some other test cases, like 2, 6, 10, 9, and 3. Okay, let's submit it. It should give TLE, according to me. Yeah, running for a long time. Okay, wrong answer. Okay. Let's see how many test cases we passed. 66. Okay. Yeah, it won't work here because if k is equal to 0, then answer will be 0. If k is equal to 0, then just return 0. I'm expecting a TLE. Because there must be some optimization work that we could. Okay. Oh, I have to take it more seriously. So it won't work on this because yeah, I can't start from I itself. I have to start from I plus 1. That's why it is giving me wrong answer. Because I can't say like, oh, 5 minus I equal to 0. So there are many zeros inside it. Okay. Well, the last case will be the one which will give the TLE. Let's see. Yeah. So this is what we were waiting for. Okay. So this is long. And we need to find minus 682. Okay. According to the hint given, we have to use Hashmap by storing some frequencies. Sum is sum 0j minus sum of 0i. Okay, that's what the question wanna suggest. See, the thing is, if we are if we have taken 2 minus 3 then 1 5 8 something like this, so here sum is 0 initially, here 0. Now let's create prefix sum array. Okay, so 0 2 minus 1, again it will be 0, then 5, then 13. If we need to get k, okay, so every pair, like for okay, yeah, I understood it. So let's suppose we are at 0. Okay, we have first some frequency 0 and k is equal to 5. Okay, so we want to check where are the places where k is equal to 5, such that here and other places. So for each of the sum, for each of the possible sum, okay, for 0 I have also taken k, and for 5 I have also k. Oh yeah, for each I store all the elements which are at right of it. Okay, for 0 I'm gonna store all the indexes at the right. So let's suppose 0 is having the first 0th index and 0 1 2 3 4, sorry 3, 0 and 3. So whenever we find k, we will say, whenever we find k, or we find 5, like our count of k is like 5. Okay, so we will say that for each of these we can get this answer, this as answer. So 5 cross 3 will be our answer. Okay, so what we will do now, we will append all the sums frequencies and with their indexes. Okay, frequencies and their indexes also matter, like yeah, frequencies and their indexes also matter. So for each I have to traverse only that index. Okay, let's do this now. So for 5 I have to traverse all the indices of 0. If it is less than 5, index of 5, then it's okay, I'm gonna add it, or else not. Okay, so let's take dictionary. So I have to use a lot of index to solve this problem. So what will it contain? It will contain some frequencies equal to default list of list. Or can we make use of count? Actually can't, because if 5 is here, like sum till here is 5 and sum till here is 0, then the sum between this is 0 minus 5 equal to negative of 5. Okay, but there is a 0 at this side too. Let's suppose there's another 0. This also won't work. So we have to count all the left side zeros. Okay. Yeah, it contains all the zeros to the left side. default list of list and some frequency of the sum of I, pre-sum of I, not pre-sum of I, of I minus 1 equals previously it was good I minus 1 dot append I. Yeah, it will work. So for each index I am appending this, and initially some frequency of 0 equals minus 1, because 0 can be found in a way always. So some frequency of Preq-sum of I dot append I minus 1. Okay, yeah, it is good. Now I will traverse the whole array. Okay, not whole array, I will traverse the pre-sum. Okay. Now for I, rather instead of using this, I can simply use for pre-sum. Okay. No, I have to use from 1 to last. For I in range 1 comma length of nums of plus 1. For j in pre-sum of, not pre-sum, for j in some frequency of pre-sum of I, k minus this. Okay, I will take k minus this if j is less than I minus 1. Okay, or rather I should better append I in here. So if j is less than I, then result count plus equal to 1, result count plus equal to 1, else break this loop, because after that we are gonna get only increasing number, else break it. Okay, on this loop, break this loop, the second one. So now we can simply return res count. So what I am doing is I have already appended all the indexes of pre-sum of I. Okay, and whenever I found one, so all I will again traverse all the indexes which have the same count, and if we found anyone, then simply append it. Okay, but one more thing could be done, that we can have our count of it. Okay, let's run it at first. Okay, output is 0. Initially it was 0. Okay, the sum of frequency of the and 0. Okay, for the 0th index I have 0. Sum of frequency of T-sum K minus T-sum of I. If J is less than I. Okay. Why is it returning? Okay, let's try on it. -1, -1, 1. Let's print some frequency. What is some frequency? Let's print some frequency. And then let's try to print P-sum. Some frequency is for 0, it is -1, cool. For -1, it is 1 and 3. How? For -1, it should be K, yeah. For -1, it should be -1 and 3. Okay. Cool. For 0, it is 0. And for -2, it is 2. Okay. So I have to find 0. When I found that sum here is -1, I will check for 1. The sum till here is -1. Then I will check for -1 again. So if I have a sum of K, then I will check for 0. Why? Because K minus P sum of it. If I have sum of -1 till here, then I will check for -1 again. So the another -1 is at here, at this place. Okay. So for I in range, okay, let's see this. Okay. So for I in range 1 comma length of nums plus 1. Okay, so -1. So I'm taking. So pre-sum I is -1, -2 and -1. And some frequencies of -1. So J in some frequency of -1. Okay. So for J in some, these are 1 and 3. So if J is less than I, what are I's? I's are 1, 2 and 3. So if J is less than I, then result count plus equal to 1. It should be equal to 1, no? It should be plus equal to 1, because it is, instead of some frequency, it should be some indices. Okay. So some frequency for 0 minus -1 for 1. Okay, it would matter. It would matter. Okay, let's print J and I. Print I and J. Oh, it's 40 minutes again. Shit. Okay, it is never going inside this flow. So instead of it, I'm gonna print sum of this one. So let's print this and I. So once it is 1 and another time it is 2 and then 1. Okay. Let's take the prefix sum. So prefix sum will be -1, -2 and -1. So yeah, this is prefix sum. 0 comma this. So we are seeing that some frequency of k minus prefix sum is some frequency of 1, 2 and again 1. Prefix sum is itself negative. So k minus prefix sum plus k. Okay, so I have to find the positive one. If I am at right and I am left with some negative value, okay, the thing is this should be prefix sum of I minus k. Okay, because if we found our k at right, now we are at left, then okay, 1 second. So we are interested in, we do have our prefix sum of I. Okay, we are interested in all the k minus prefix sum of I. So it was correct before. Yeah. So we have our prefix sum of I at I. Okay, we are interested for all j's in some frequency before it, with whose sum is k minus prefix sum of I, such that we add both of them and k will be remaining. Okay, so k is 0 and k minus prefix sum every time is 1, 2 and 1. Okay, no big deal. So I found that there are two ones. So here is a 1 and another here is a 1. We can say it here. Okay. We are at k. We are at prefix sum of I. Exclude that from k. If prefix sum of I is itself -1, -2, -1, so prefix sum of I minus j should be k. Okay, so instead of finding this, I should find k plus prefix sum, such that oh no, it should be minus. Okay, prefix. Yeah, I was correct. I need to find all prefix sum minus I, such that prefix sum minus. Okay. I was confused for it for a really long time. So the thing is, we should rather find prefix sum. Okay, let's remove it all. So what I have to find is prefix sum at I. We found that there is a prefix sum at I. Then we have to find some other prefix sum of I minus k. Then we will subtract this. So this is underscore minus this will be equal to k. I was taking it wrong for like this was really a grave mistake. So instead of taking this, I should take k minus prefix sum of okay, prefix sum of I minus k. Yeah, prefix sum of I minus k. Now it will work fine. And 20 lines of code I am taking for more than 40 minutes. Yeah, it worked fine. Let's check it on another other test cases. I'm printing both of these. Let's remove it. I already have a big test case. Let's take this. Okay. Let's run code on it. Okay, accepted. Yeah, now it will get accepted. So again, it was I actually used hint to find out how to use Hashmap. So according to it, you see there this is 5 seconds. That's why it worked also. Okay, so here it said that some frequencies will be helpful. Then I found that okay, if I am having okay, let's make it simplified. If at ith position, if ith position I have something a plus k, okay, and if jth position I have some k or not k a, then a plus k minus a will be k. So I have to find all j's before this to calculate it. So I have used Hashmap to store all the sums indexes. Okay, here sums indexes, it should be index not frequency, sums indexes, and finally traverse it to find the answer. Okay, thank you guys, it's done.